Welcome, everyone. Today, we're going to talk about a massive elephant in the room when it comes to AI development, the illusion of control. We all like to think that when we give an AI agent a step-by-step plan, it follows it exactly as instructed. But after analyzing nearly 17,000 SWE agent trajectories, the empirical data tells a completely different, and much messier, story. Here is the standard industry assumption. You write a strict system prompt, navigate, reproduce, patch, validate, and you expect a neat, predictable, step-by-step execution. But here is the empirical reality: your plan is only advisory. The second the agent starts executing, your beautifully crafted scaffold is hijacked by its own internal model biases and the overwhelming gravity of its growing context window. To actually see what's going wrong, we had to measure the invisible. We built something called the languatory translator. This tool takes thousands of raw, granular agent actions and abstracts them into 4 core phases: navigation, reproduction, patching, and validation, or N, R, P, V. This finally allows us to read an agent's true strategic footprint. With this translator in place, we evaluate the agents across 4 dimensions of plan compliance. First, the phase check: did they complete all the steps, or skip some? Second, the fidelity check: did they hallucinate or invent out-of-bounds steps? Third, the order check: did they actually follow the sequence we asked for? Combine these, and you get the overall plan compliance, or PC score, the ultimate indicator of whether the agent is actually listening to you. So, what is the baseline? What do they actually do? Well, look at this topography flow map. Almost no one stays on the straight, instructed path. Models like GPT-5 Mini and DevStro immediately start creating their own alternative routes and out-of-plan loops. Now, compliance does correlate with success. The agents that solve the problem generally stick closer to the plan, but a perfect execution of the standard plan is incredibly rare. In fact, different models have vastly different personalities when it comes to following instructions. GPT-5 Mini is the adaptive pragmatist. It modifies the plan on the fly, skipping steps if the task looks easy, but it relies way too much on the validation phase to fix its own rushed mistakes. DevStro is the strict rambler. It tries to follow your order, but it adds a ton of unnecessary, out-of-bounds junk along the way. DeepSeek V3 is the focused skipper. It doesn't hallucinate junk steps, but it prematurely converges and skips vital validation steps. And DeepSeek R1 is the fragile reasoner. It optimizes for short-term rewards and completely breaks down if your plan isn't perfect. Slide 7, Stress Test 1, The Void, No Plan. To really understand these behaviors, we ran some stress tests. Test 1 was the void, giving them absolutely no plan. The result? Success rates drop across all 4 models. Without guidance, they fall back on their internalized training, which naturally mimics our NRPV workflow, but their reasoning becomes totally unfocused because they lack structural discipline. Test 2 looked at incomplete plans, and the takeaway here is crucial: a bad plan is substantially worse than no plan at all. If you tell GPT-5 Mini to skip validation, it loses its ability to refine its work and fails heavily on hard tasks. Worse, if you tell DeepSeek R1 to skip reproduction, it experiences catastrophic failure, literally entering a death loop of malformed tool calls in hundreds of instances. Test 3 explores the augmentation trap. As engineers, we love adding best practice steps to prompts. But over-instruction causes overfitting. When we added regression testing to DeepSeek V3, it got permanently stuck in environment setup loops. When we added a simple PR summary step for DeepSeek R1, the system crashed entirely over 400 times. If the new steps don't align with the model's pre-trained internal strategy, performance tanks. And if you give them a sequence that actively harms problem-solving? Welcome to Test 4, the Adaptive Rebel. When we purposefully gave DevStro and GPT-5 Mini a suboptimal execution order, they explicitly ignored our instructions. They bypassed the prompt because effective workflows trump prescribed workflows. Capable models will rebel to get the job done. A major reason for all this drift is context window gravity. As an agent works, error messages and file contents pile up, and your original prompt at the top of the context window simply fades away in influence. The incredibly simple fix? Periodic reminders. Injecting a reminder of the plan dramatically improves compliance and task success across all models. You can see this clearly in the plan mutation matrix. That bottom row, the reminded state, is green across the board. Meanwhile, explicitly removing core steps like reproduction or validation creates a sea of red and orange failure states. This all comes to a head when we look at SWE Bench Pro, the genuinely hard, zero-contamination tasks. On these harder problems, plan compliance drops by 13%. The standard checklist completely fails to guide the agents, leading to repetitive looping where they just give up before ever reaching the validation phase. Hard tasks require adaptive reasoning, not rigid checklists. So, what are our takeaways? There are 3 core themes. First, the illusion of control. System prompts are advisory, and local context will override your global instructions. Second, the danger of bad plans. Poorly constructed or incomplete instructions will actively crash your agent. Third, the non-determinism factor. You simply cannot prompt a model into a framework it does not internally understand. This leads us to the alignment imperative. Your instructed plan in the system prompt must significantly overlap with the model's internalized strategy, its pre-trained weights. That overlap is your zone of successful execution. Anywhere they conflict, the agent will rebel, hallucinate, or crash. Which brings us to a new paradigm for agentic workflows. The old engineering way was to furiously type complex, hard-coded plans into a system prompt, begging the agent not to deviate. That era is over. We need to shift our focus to adaptive fine-tuning, teaching models how to follow plans and reason adaptively on the fly. Because ultimately, the future belongs to agents that reason, not agents that read. Thank you.